Hello Year 11, it's Mr. Miller here. Hope that you're doing well. This is the next past paper video. This time we're on to the 29 series. This is paper 1, so it's a non-calculated paper. Hopefully you have spent 90 minutes doing the paper first. As always, if you want to go through all the questions with me, I'm going to go through all the questions today, but please make sure that you have had a go at the questions first. Let's start off with question 1. Okay, question 1 said there are only blue, red, and yellow cubes in a box. We've got a table. We know the probability of blue. And then it says the number of red cubes is the same as the number of yellow cubes. So the approach that I taught you to do this is to call them one of them X. Well, actually, we're going to call both of them X because they're the same. And we know that probabilities sum to 1. So 0.2 plus, well, I can just write 2x, can't I? And it sums to 1. So this is a nice and easy equation to solve. I'm going to minus 0.2, 2x equals 0.8, and then divide by 2, x is equal to 0.4. You could have done that in your head rather than make an equation, but I'm just going to write in the table 0.4. There are 12 blue cubes. Work out the total. Okay, 12 blue cubes. So I can actually just write in my table 12 under 0.2. And if there's 0.2 blue and red and yellow is 0.4, well, I think that's just double, isn't it? So I can do 24 for red, 24 for yellow, and then add them up. 12 plus 24 plus 24. That is going to be 60 cubes in total. Other way I could have done it is I could have said 0.2 is equal to 12 blue cubes, and I want the total, which is 1, so I can times by 5 on both sides to get 60 in total. So 2 nice ways of doing that question. Hopefully you all got that, hopefully nice and straightforward. Okay, question 2. Dion needs 50 grams of sugar to make 15 biscuits. Okay, so 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar. So 3 times as much flour. So I can just write she needs 150 grams of flour, because that is 50 times 3. And then 2 times as much butter. So I can write she's going to need 100 grams of butter. Okay, Dion is going to make 60 biscuits. Work out the amount of flour she needs. Okay, so I knew that to make 15 biscuits, I worked out already that she needed 150 grams of flour. So to make 60 biscuits, how do I get from 15 to 60? I just times by 4. So times that by 4, and we could just do a nice simple calculation here. That's going to be 600 grams of flour. So I'm going to write that on the number line. Answer line, 600 grams. Then it says for part B, Dion has to buy all the butter she needs to make 600 biscuits. She buys the butter in 250 gram packs. How many packs does she need? Okay, so I think the first thing I need to work out is how much butter she needs. So I'll go back to my original, which was 15 biscuits. She needs 100 grams of butter. So for 60 biscuits, again, I'm just going to times by 4. Times by 4, so 400 grams of butter. So if I need 400 grams of butter and she buys the butter in 250 gram packs, well, I just need to use a bit of logic here. 1 pack's not going to be enough, but 2 packs is going to be enough because 250 times by 2 is 500. So I think I'm just going to write 2 packs on my answer line. Hopefully, again, that was nice and straightforward. Question 3. Okay, find the highest common factor of 72 and 90. So 2 ways of doing this. I could list out all the factors, but actually I'm not going to do that because I might miss one of them. So I'm actually going to do this by my prime factor trees, which I know that you're very comfortable doing. So I'm going to do it very quickly. And then 90, I'll do that here. So I'll just do 9 times 10, 3 times 3. Okay, so let's write these out. So 72 was 2 times 2 times 2 times 3 times 3. 90 was 2 times 3 times 3 times 5. And I'll do my Venn diagram. So 72 here, 90 here. What factors do they have in common? Well, they got 1, 2, goes in the middle. No more 2's in common, but they've got 1, 3, and another 3 in common. And so what is left? Well, 2 2's for 72 and a 5 for 90. So my highest common factor is all the ones in the middle multiplied together, which is 18. So definitely practice this if you are not so confident, but hopefully this was okay for you. Okay, this one is an interesting question. The diagram shows the plan, front, and side elevation of a solid shape. Okay, so I know when I'm given these questions, I know I'm going to be looking at a 3D shape. So I need to figure out which one it is. Well, if I'm looking at it from the plan view, i.e. straight down on it, it looks like a circle. So I think this is going to be a cylinder. So let's make a sketch of a cylinder. Something like this would be a good sketch. There is a cylinder. And let's think about what the dimensions I need to draw on here. So if I think about the diameter of the circle, that is 1, 2, 3, 4. So I can put that here, 4 centimeters. And then the front and side elevations, well, I'm going up by 5 both sides. So if I look at it from the front or the side, the cylinder has a height of 5 centimeters. So that is all I would need to draw on that cylinder. Let's keep going. Okay, this was question 5. And it said shape A can be transformed to shape B by a reflection in the x-axis, followed by a translation CD. And I need to work out the value of C and the value of D. Okay, so I think it makes sense to do my reflection first, reflection in the x-axis, so that is here. So how do I do this? Well, I take all of the points one at a time, and I see how many do I need to get to the x-axis. So let's take this one first, 1, 2. So I'm going to go 2 down, 1, 2. So it ends up there. Different color, 1, 2. So 1, 2 down here, and then we'll use a green for this one. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So there's my shape. Now let's draw it. That's the shape. And then it says a translation CD. Now I know when I have a translation, the top one tells me how much I'm going right or left, and the bottom one tells me up or down. So let's have a look at this translation. So let's pick 2 points that are on the in the same place. So let's go for this one down here and this one down here. And first of all, let's see going right or left. So I'm going to go left, 1, 2, 3, 4, 5, 6, and then down 1. So because I'm going left 6, that's going to be -6, and down 1, that's going to be -1. We're going to do a revision lesson on transformations next week, but this was -6, -1. Hopefully nice and straightforward. Okay, this one was a little bit tricky. A shop sells packs of black pens, packs of red pens, and packs of green pens. So the important thing is that in the first part of the question, it says there are 2 pens in each pack. So the first thing is saying how many pens are in each pack. And then the second thing, it's telling me the number of packs sold. So before I do anything, it tells me the number of pens that are sold. Well, I'm not actually going to use this ratio here. I'm not going to use that one because that doesn't tell me the number of pens. That tells me the number of packs. Tells me the number of packs. So how do I get from the number of packs? I want to get from the number of packs to the number of pens. Well, I'm going to need to multiply by how many pens there are in each pack. So 7 times by 2, I'm going to do 3 times by 5, and I'm going to do 4 times by 6 to get the number of pens. So what's that going to be? 7 times 2 is 14, 3 times 5 is 15, 4 times 6 is 24. So that is telling me the ratio of pens. I'm just going to write that here, number of pens. But I'm told that the total number is 212. Okay, so what would be the total number of parts here? The total number of parts is going to be 14 plus 15 plus 24, which is, I think, 53. And there are 212 pens in total. So what's my scale factor? Well, that's not easy, but if I test out 53 times by 4, let's just see. And yeah, that is 212. So that's my scale factor times by 4. And I want the number of green pens sold. Which one is green? That is, so it's black, red, and green. So I'm going to do 24 times by 4. And I'm going to get 96. So the green is 96. So a bit of a tricky one there, but this kind of question does come up where you have to go from the number of packs to the number of pens or equivalent, something to do with that. Okay, let's keep going. Okay, here are 2 rectangles. Okay, let's see what we have on, in the question. QR equals 10. Okay, let's put that on the diagram. QR is 10 centimeters. And also, obviously, PS is going to be 10 because it's the same side of the rectangle. And let's just take that bit of information off. BC equals PQ. So let's just, I don't know what they are yet, but I know that they are the same. So all of these sides are the same. The perimeter of ABCD is 26. Okay. Now the area of PQRS is 45. So this one has an area of 45. So what can I work out? Well, I think I can work out this length SR because I know one side of the rectangle and I know the area. So 45 divided by 10 is 4.5 centimeters. And because that is the same as this length here, BC, 4.5 centimeters, this is also 4.5 centimeters. And I know that the perimeter of ABCD, perimeter was 26. I think I can work out the length of AB. So let's call that length X. This length is also X. And I can set up an equation for perimeter. So X plus X, 2X, plus 4.5 plus 4.5, that is just 9, equals 26. I got 2x equals to 17. And divide that by 2. Hopefully you can work that out in your head. AB, or x, was 8.5 centimeters. Hopefully quite a straightforward one there. Let's keep going. Okay, work out an estimate. An estimate, that always means I need to round for the value of square root of 63.5 times 101.7. Okay, because I've got a square root sign, I'm looking for numbers which are square numbers. So is there a square number close to 63.5? Well, yeah, 63.5 rounds to 64, which is 8 squared. What about 101.7? Well, yeah, 100 is a square number because that is 10 squared. So this is the same, this is the same as splitting up these square roots. And I can just write this as 8 times 10, which is obviously 80. Part B. Now, actually, this was a really tricky question. I remember Year 11 a few years ago had this paper in their mocks, and very few people got this question right. So it was only 1 mark, but I'll take a bit longer maybe to explain it. So 2.3 to the power of 6 equals 148. Correct to 3 significant figures. Find the value of 0.23 to the power of 6. Okay, well, let's think about this. So if I compare 2.3 to 0.23, well, how do I get from 2.3 to 0.23? I'm dividing by 10. So I'm going to move the decimal point back once. But what about 2.3 to the power of 6 and 0.23 to the power of 6? Well, I actually think rather than divide by 10, I'm going to have to divide by 10 to the power of 6, because each time I'm moving back 1 decimal place. So I'm actually going to have to take my answer, which is 148, and move back my decimal point 6 times. 1, 2, 3, 4, 5, 6. Fill in the zeros, and that is going to be my answer, 0.000148. So very tricky one, I think. A lot of you may have written, I think 14.8 would be a very common answer. But if you think about why it can't be 14.8, well, it can't be that because 0.23 times by 0.23 is going to be less than 1. And the more you multiply by 0.23, the smaller and smaller it's going to get. So hopefully now you realize that the answer has to be 0.000 something. Okay, not sure if that was the best explanation, but that is one way to think about it. Next question. Well, actually, this was at part C of the same question. So this was just a nice, easy 1 mark question. Negative power, I'm going to take the reciprocal of the 5 and then square it. So that should have been a straightforward 1 marker there. We've done that in class recently for revision as well. Okay, question 9 was a nice fraction multiplication. So hopefully you all got this. So first of all, you should have converted them to an improper fraction, and then multiply the numerators, multiply the denominators. Make sure you read the question. So we want a mixed number in its simplest form. So let's first write this as 5 6/10, which we can simplify as 5 3/5. So hopefully that was a nice, easy 1 mark question. Okay, question 10. The graphs with equations 3y plus whatever and 2y minus whatever have been drawn on the grid. And it says, using the graphs, find estimates of the solutions of the simultaneous equations. Okay, so this was actually looked like a nasty question, but all you need to remember with these types of questions is that the solution of 2 simultaneous equations on the graph is where they meet. So this point here was our x coordinate, and when I did this earlier, I got x equals 2.3, and our y coordinate I got was minus 1.3. So hopefully a nice easy 2 mark question. Just remember when you've got graphs and you're asked to solve simultaneous equations, you look where they meet. Okay, question 11. We did this not too long ago, so hopefully it was okay. So we had the ages of 23 people on coach A. You complete the table below to show information, and we have to find the median, the lower quartile, and the upper quartile. Okay, so the technique that I told you to do is I underline the smallest and the biggest, and keep going until you get the median, the middle number. So just taking my time, not rushing, and I'm left with my median being 59. Now, to find the lower quartile, you need to take all of the ones below the median and then find the middle number here. So we're going to cross off the smallest, cross off the biggest. Smallest, biggest. Keep going. Keep going. And that is my lower quartile, 53. And then the same for the upper quartile. I look at all of the ones above the median, and then I should be able to see what the upper quartile is going to be. Yeah, 66. Okay, here's some information about the ages of people on Coach B. Okay, Richard says that the people on Coach A are younger than the people on Coach B. Well, let's have, what are they asking us here? Younger. I think I'm looking at the average age or the median. So let's look at the median. For Coach A, it is 59. For Coach B, it is 70. So quite old people on this coach. So is he correct? Yes, he is. Because the median for Coach A is smaller. So the people are younger. So smaller median, and I'll just give the data. 59 versus 70. Richard says that the people on Coach A vary more in age than people on Coach B. So when it's talking about vary or variation, we're looking at the interquartile range. So let's actually figure out the interquartile range. For Coach A, it is 66, the upper quartile, minus 53. And for Coach B, 73 minus 54, which is 19, I think. So do they vary more in age in A? Well, no, because the interquartile range is smaller, which means there's less variation. I'm going to say no, the interquartile range is smaller for Coach A. 13 versus 19. Okay, next question. Here are three spheres. This, I remember marking the old year 11 mocks, was a very tricky question. The volume of sphere Q is 50% more than the volume of sphere P. Okay, so 50% more. The volume of sphere R is 50% more than the volume of sphere Q. 50% more. Find the volume of sphere P as a fraction of the volume of sphere R. So with this question, you're not told what the volume of any of the spheres are. So it's a little bit confusing. How can you work out what the volumes are if you're not told the volume of any of them? Well, actually, if you think about it, it doesn't really matter what the volume of any of the spheres are. Whatever the volume is, there's always going to be the same link between them. So what I would do here is I would call the volume of sphere P 100. Let's just call it 100. I think it does this in the model answers as well. So what would be the volume of Q? The volume of Q, well, 50% more. How would I do this? Well, 50% of 100 is 50. So 50% more would be 100 plus 50, which is 150. So the volume of sphere Q is 150. Same thing for R. What's 50% of 150? Half of 150 is 75. So 150 plus 75 was 225. 225. You could have also multiplied by 1.5. That would have given you the same answer. So let's go back to the question. Find the volume of sphere P as a fraction of the volume of sphere R. So what does that mean in words? Well, that means the volume of P as a fraction of, so over, volume of R. What was the volume of P? Well, I called it 100, and R was 225. And I can, it doesn't tell me to leave my answer in its simplest form, so I can just leave my answer like that, and it is okay. So yeah, when you get these kinds of questions, when you're given a ratio or given a percentage link between things, just say, let the volume of one thing be something. You could have been 100, it could have been 1, it could have been 20, doesn't matter. You're going to get the same scale factor link between them. Okay, given that n can be any integer such that n is bigger than 1, prove that n squared minus n is never an odd number. Okay, never an odd number. Well, if it's not an odd number, that must mean what? It must mean it is always even. Okay, so how do I do this? Well, there's a number of ways to do this. One thing that you could do is you could start by thinking, can I factorize this? And yeah, you can factorize this. You don't have to, but it's actually going to make your life a little bit easier. So I factorized it to make it like this. Okay, so this is a proof question that we did look at, but we haven't really recapped it. So it's good to do that. Good that this question came up. So given that n can be any integer can either be odd or even. So let's have a think first of all. If n is odd. So if n is odd, so n is odd, what does that mean n minus 1 is? Well, I think that n minus 1 is going to be even, because numbers go odd, even, odd, even, odd, even. So if I have an odd number, minus 1 from it, I get an even number. So if n is odd and n minus 1 is even, what's happening here? Well, I'm doing an odd times an even, which is always going to be even. Because if you multiply an even number by something, and the answer is always going to be even. But I need to do the other situation as well. So what about if n is even? Well, n minus 1 is going to be odd, but then I've still got an even times an odd, which is an even. So let's just write the conclusion. Therefore, whatever the value of n squared minus n is always even. And that would be good enough for my answer. Okay, let's keep going. See if I can do this in one take. Okay, question 14. Find the exact value of tan 30 times sine 60. Now, when you get to your mocks, paper 1, you do need to know your exact values of your trig. So you do need to know them. Now, you don't have to memorize them. You could if you wanted to, but an alternative is you could draw out a triangle and derive them. This is what we did in year 10. I'll just remind you what we did. So if I start off with an equilateral triangle with length 2, and I split it in half to get a right-angled triangle, this length here is 1, and this angle here is 30, well, I can work out the height of this right-angled triangle by using Pythagoras, and that is root 3. And actually, I can find all my values of tan, cos, and sine 30 and tan, cos, and sine 60. Let's do tan 30 first. So tan 30 is my opposite. Opposite to 30 is 1 over my adjacent. The adjacent to 30 is root 3. So that is my value of tan 30. And sine 60, well, if I use this 60 degrees, that is opposite over hypotenuse. The opposite side to 60 is root 3, and the hypotenuse is 2. So if I multiply these together, I can cancel out these root 3's, and my answer is a half. So you could draw out your triangles, or you could in the exam, I've seen students before, learning this, learning the tables for sine, cos, tan of 0, 30, 45 you need to know, 60, and 90. So I've seen students learn that table, but you can also do it by drawing out your triangles and working them out. Okay, question 15. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 10. Okay, you can see that. The base of the cone has diameter 6. The hemisphere has also a diameter of 6. The total volume of the shape is k pi, where k is an integer. Okay, so for this one here, I think I need to work out two things. I need to work out the volume of the cone, and I need to work out the volume of the hemisphere, and then add them together. Now it's giving me my formula, so I'm definitely going to need to use those. Let's do the cone first. So let's do the cone. My formula is 1/3 pi r squared h. And now I need to think, what's my radius? What's my height? Well, I'm not given my radius, am I? I'm given my diameter. My diameter is 6, so my radius has to be 3. So my radius is 3, and my height, I can see, is 10. Okay, let's simplify this. 3 squared is 9. 9 times 10 is 90. 90 divided by 3 is 30. So I get 30 pi. Okay, now hemisphere, a little bit harder. There's two things that you could do here. One thing that you could do is work out the volume of the sphere first. So the volume of a whole sphere would be 4/3 pi r cubed, and then I'm going to divide that by 2, because I've only got half of it. So a sphere, 4/3 times pi. Now the radius is not 6, it's 3. Now, 3 cubed, 3 times 3 times 3 is 27. 27 divided by 3 is 9. 9 times 4 is 36. So the hemisphere is going to be half that. Half of 36 pi is going to be 18 pi. And so add them together, the total, well, my cone was 30 pi, my hemisphere was 18 pi, 48 pi in total, but it wants my value of k. K is the coefficient of pi. K was 48. Okay, let's keep going with the next question. Okay, question 16. There are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, 5. The 3-digit number 553 is one way the dials can be set as shown in the diagram. Part A, work out the number of different 3-digit numbers that can be set for the combination lock. Okay, this is a nice question, and we did this not too long ago. And the way to think about this is to think, how many different combinations can there be for each part of the log? Well, for the first one, the first digit could be 1, 2, 3, 4, or 5. So there are 5 combinations. What about the second one? Well, I can use the same number here. I think there's also going to be 5 different ways. And same thing for the third one. So 5 times 5 times 5 is going to be 125. Because remember, I multiply, this is called the product rule, so I multiply each of the combinations together. Part B. How many of the possible 3-digit numbers have 3 different digits? Okay, well, how is this going to be different? Let's think about it. For my first digit, again, it can be any number. So again, I've got 5 possible options. But what about the second one? It has to be different. Let's say I've used up a 1 already. I've only now got a 2, a 3, a 4, or a 5 to choose from. So I've only got 4 different digits left. And for the third digit, again, I need to minus 1 because I've now used up 2 different digits. So I've only got 3 left. So 5 times 4, which is 20, times 3, my answer is 60. So really important you understand the difference between part A and part B. In part A, I could have any of the 5 digits each time. But in part B, I couldn't repeat the digits. So I had to minus 1 each time. Next question. Okay, this is a ratio question. We are given that x squared to 3x plus 5 equals 1 to 2. Find the possible values of x. So you need to remember the approach that we take with this one here is that if I've got 2 ratios and an equal sign, I'm going to write x squared over 3x plus 5 equals 1 over 2. That's the approach you're always going to take. Then you're going to, of course, cross multiply. So cross multiplying here, 2 times x squared gives me 2x squared equals 1 times 3x plus 5 is just 3x plus 5. So this is a quadratic equation. Let's minus 3x and minus 5 on both sides. We've done a lot of this recently. Make everything equal to 0. And now I need to factorize. How do I do this? Okay, let's find 2 numbers that multiply to give not minus 5, but 2 times minus 5, which is minus 10, and add to give minus 3. What are these 2 numbers? Minus 5 and 2. Now what do I do? Well, remember, I need to rewrite out the quadratic, 2x squared, but split up the minus 3x. So split that up into minus 5x and plus 2x equals 0. Okay, now I'm going to do a dotted line here, factorize both parts. I can only take out an x from the first part, 2x minus 5, plus, I can't factorize the second part, that's okay. I'm going to write plus 1, 2x minus 5 equals 0. Now combine them. X plus 1, 2x minus 5 equals 0. So, x1 equals, what makes that bracket equal to 0? Minus 1. Now this one here, how do I work out what x is? 2x minus 5 equals 0. Solve the equation. 2x equals 5. X equals 5 over 2. So let's just write my answers as x1 equals minus 1, x2 equals 5 over 2. Those are my answers. We're definitely going to do a revision lesson on ratio because when you get questions like this, you really need to be able to do the first step. And once you do that, you should be able to get lots and lots of marks. Let's keep going. Okay, a third question for question 18. First part, express root 3 plus root 12 in the form a root 3. Okay, well, root 3 is already in the form a root 3, so let's leave that. What about root 12? Well, I need to simplify this. and I know that one of the thirds has to be root 3. So what times by 3 gives me 12? Obviously 4. Now let's rewrite this. What is root 4? The square root of 4 is 2. So how do I simplify this? Well, I've got one lot of root 3 plus 2 lots of root 3, altogether 3 lots of root 3. Okay, second part looks very nasty. Express 1 over root 3 to the power of 7 in this form. Okay, well, what do I do here? Well, one thing I could do is let's just write all of this out. So I'm going to write this 7 times. And hopefully I'm going to be able to spot what I'm doing here. That's 6 and one more 7. Okay, well, how could I make this problem easier? Let's just take a look at 1 over root 3 times by 1 over root 3. Let me do that to the side here. What do you do when I multiply fractions together? Well, multiply the numerators, multiply the denominators. 1 times 1 is 1, and root 3 times by root 3 is just 3. So that combination gives me 1/3. But so does this one, and so does this one. And I'm left with 1 over root 3. Now, let's multiply out all of these fractions. What are the numerators? They're all 1. 1 times 1 times 1 times 1 equals 1. Now the denominators. 3 times 3 times 3 is 27. So it's 27 root 3. Now I think I need to rationalize the denominator here. So 1 over 27 root 3. Because I've got a root 3 in the denominator, I think I need to multiply by root 3 over root 3. So what is this? 1 times root 3 is just root 3. Now, root 3 times root 3 is 3. So all I'm going to do is 27 times by 3, which is 81. So my answer, is that in the form root b over c? Yes, it is, because b is equal to 3 and c is equal to 81. So actually, this problem was quite tricky, but once I wrote it out and simplified it, it became a lot more manageable. I did a little bit at a time and then put them all together, rather than try to do like something to the power of 7 all in one go. Good question, let's keep going. Okay, given that x squared minus 6x equals x minus a all squared minus b, find the value of a and find the value of b. Now, what type of question is this? Well, hopefully you recognize this. We've done this very recently, but if you weren't sure, part B could have looked ahead, and it says coordinates of the turning point, which means I think it's going to be completing the square, which we have just done very recently. So completing the square, what do I do? Well, I'm going to do x minus half of 6 is 3. And when I do this, 3 squared is 9, so I need to minus 9 and plus 1, which simplifies to make x minus 3 all squared minus 8. So what is my value of a? Well, x minus 3. So a is 3 and b is 8. And part B, the coordinates of the turning point, well, remember, your x value is what makes this bracket equal to 0. So x is 3. That is my x coordinate. And my y coordinate is 0 minus 8, so it is just minus 8. Let's keep going. Okay, question number 20. I've got some proportions here. So h is inversely proportional to p. P is directly proportional to root T. And then I'm told some values. Find a formula for H in terms of T. Okay, let's take this one step at a time. So I think my first step is going to be finding an equation between H and P. So I can write H equals K over P because it's inverse proportion. What are the values that I substitute in? Well, I've got H is equal to 10 and I've got my value for P. P is equal to 6. So I'm going to write 10 equals K over 6. So to find my value of K, I multiply by 6 and I get K is equal to 60. So let's rewrite that equation. H equals 60 over P. That is my first equation. Change color. P is directly proportional to root T. So that's step 2. Let's do that over here. What equation can I write? So P is equal to directly proportional, so K root T. Let's hold my values. So T is equal to 144, P is equal to 6. So 6 equals K root 144. And the square root of 144 is 12. So dividing both sides by 12, 6 divided by 12 is a half. So I can write that as P is equal to a half root T. So I reckon I've already got a couple of marks here. Now my final step, it says find a formula for H in terms of T. So what does my answer need to look like? My answer needs to look like H is equal to something T. So let's start off, this is going to be step 3. Let's start off with what H is equal to. Where can I find what H is equal to? Well, using my equation 1, H is equal to 60 over P. But I don't want that because I want H in terms of T, sorry. So how can I do that? Well, I know an equation for P. P is equal to a half root T. So I can rewrite this as H is equal to 60 over a half root T. And that is going to be my answer. Now, I could actually simplify this a little bit. If you wrote this on your number line in your answer, you would get full marks. But let me just show you if they ask you to simplify this. So I can write this as 60 divided by a half root T, I can write as root T over 2. That's the same thing as a half root T. And now I can kiss and flip. So 60 over 1 times by 2 over root T. And this is going to be 120 over root T. So I could, if I wanted to, rewrite this as H is equal to 120 over root T. But if I wrote the first thing, then I would have gotten the marks anyway. So nice question there. So hopefully you got at least 2 marks. That third set was a bit tricky, but let's just highlight what I did there. Instead of P, I wrote a half root T because that was what P was equal to. Almost there, a few more questions to do. Okay, so question 21 is a functions question, so that's good, we've done that recently. It's given me 2 functions. I'm going to do part A on this page and then part B on the next page. So f inverse of x. So you should remember how to do this. My first step, instead of f is equal to x, y is equal to 3x minus 1. And now we need to rearrange to make x the subject. So how do I do this? Add 1 to both sides and then divide by 3. So I rewrite my answer. Instead of y plus 1 over 3, I substitute my y for x plus 1 over 3. So part B, let's have a look at that now. Okay, so part B of this question, 5 marks. So a lot of working that I'm going to do here. It says that given that fg of x equals 2g f of x, show that 15x squared minus 12x minus 1 equals 0. So this needs to be my answer. That needs to be my answer. Okay, so how do I approach this problem? Well, I think I need to work out what fg of x is equal to, and then what 2g f of x is equal to, and then rearrange somehow to get to my answer. So step one, let's work out what fg of x is equal to. Okay, how do I do that? Well, what is closest to the x? G. So I'm going to do g of x is equal to x squared plus 4. And now I need to do f of that, f of x squared plus 4. Now, how do I do that? Well, let's write out what f of x is equal to. So f of x was equal to 3x minus 1. So instead of x, I'm going to write x squared plus 4. So instead of 3x minus 1, I'm going to write 3x squared plus 4 minus 1. And I can simplify that. So 3x squared plus 12, expanding brackets, minus 1 equals 3x squared plus 11. So this was what fg of x was equal to. Step 2. Let's work out not 2g f of x, but let's just work out what g f of x is. And then whatever I get, I'm going to multiply that by 2. Okay, so what do I do first here? Well, I'm going to do f of x first, which is 3x minus 1. And now I need to do g of 3x minus 1. So let's compare that to g of x, which was x squared plus 4. And again, instead of writing x squared plus 4, I'm going to substitute my x. I'm going to substitute my x for 3x minus 1. So that is my new x. Okay, so how do I do this? Well, I think it would make sense to do a box. So let me do my box up here. I'm going to do 3x minus 1 times by 3x minus 1. So that is 9x squared minus 6x plus 1. But I've also got this extra plus 4. Don't forget about that plus 4. So that simplifies to make 9x squared minus 6x plus 5. So this thing here was g f of x. So what is 2g of x going to be? G f of x going to be? So 2g f of x, let's multiply all of these things by 2. So 18x squared minus 12x plus 10. Okay, I'm almost there. I'm running out of space a little bit, but should be okay if I do it. Let's do that to the side here. So step 3. I know that these two things are equal to each other. So I know that 3x squared plus 11 is equal to 18x squared minus 12x plus 10. So I've made them equal to each other, and now I need to show this thing here is true. So it says equal to 0. I think it would make sense to make the left-hand side equal to 0. So minus 3x squared minus 11 from both sides. And let's hope I get the same thing. 18x squared minus 3x squared is 15x squared. Good. Then I got minus 12x still. And 10 minus 11 is minus 1. So I have what I wanted, which is good. So I can write as required. Done. So if you have a good understanding of those composite functions, which I know a lot of you find tricky, that it was worth 5 marks towards the end of the paper. So well worth making sure that you are double, triple happy with composite functions. On to the last question now. Okay, here's the last question, and it was a tricky question, but let's go through it. So there are only R red counters and G red counters in a bag. Okay, a counter is taken at random from the bag. The probability that the counter is green is 3/7. It's put back in the bag. Okay, so let's take these first 2 lines here, and let's see if I can make some sense of this. So the probability that the counter is green is 3/7. Now, at the start, let's think about the probability of taking a green counter. So I've got, in total, R red counters and G green counters. So in total, I've got R plus G. So can I write an expression for the probability, let's write this down here, the probability of taking a green, in terms of R and G? Because I know that that is equal to 3/7. Yeah, okay, so the probability of picking a green counter is the number of green counters, G, over the total number of counters, which is why I wrote R plus G. And I know that that is equal to 3/7. Okay. Let me just get rid of those fractions there. So let's cross multiply. So I'm going to have 7 times G equals 3R plus 3G. And let's simplify. Let's get rid of the 3G. So I have 4G equals 3R. Okay, good. I've got one equation. Now, what happens next? 2 more red counters, and 3 more green counters are put in the bag. So what actually happens here? The probability that the counter is green is now 6/13. So what's actually happened? Well, I've got 2 more red counters and 3 more green counters. So let's have a think about what counters I have got. Let's think about the number of red counters. So I started off with R red counters. Now I've got R plus 2 red counters. And with green counters, I've now got G plus 3 green counters. What do I have in total? In total, I've got R plus G plus 5. R plus G plus 5. So now, the probability of getting a green counter now is the number of green counters, G plus 3, over the total, R plus G plus 5, and I make that equal to 6/13. Okay, so again, let's cross multiply here. What do I've got? What do I have? I got 13G plus 39 equals 6R plus 6G plus 30. Let's tidy this up a bit. Let's get rid of a 30. So I've got numbers only on one side. 13G plus 9 equals 6R plus 6G. And let's also get rid of this 6G here. So I've now got 7G plus 9 equals 6R. So what do I now have here? I've got simultaneous equations with 2 unknowns, G and R, and I can solve this. Now, what's the best way to solve this? Well, actually, let's have a look at both of the equations. I've got 4G equals to 3R, and 7G plus 9 equals to 6R. So let's do something to the first equation. If I multiply both of these by 2, I've now got 8G equals to 6R. And do you see why I've done that? I've done that because now I can rewrite this equation as 7g plus 9 is equal to not 6r, but 8g, because that's what the first equation tells me. And now I can minus 7g from both sides to get g is equal to 9. So I've got, at the start, 9 green counters. How do I find how many red counters there are? Well, I could use any of the equations. Let's use 4g equals to 3r. So I knew that g was equal to 9. 9 times 4 is 36. So r is equal to 12. There were 12 red counters at the start. So really nice problem there, where we had to think about how many green counters, how many red counters, how many total counters there are. We had to solve two equations, we had to cross multiply, rearrange them, and then in the end solve two simultaneous equations. So a really nice last question there. Yeah, don't be too worried if you didn't quite get that, but it's good to see this kind of equation. So hopefully next time you can do something similar to at least start this problem. Okay, that's it from me. Thanks very much.